the AllDifferent constraint is an important constraint because it occurs in many different types of problems, but it's also interesting to study because it has a very interesting filtering algorithm. As we introduce a new constraint, it's always interesting to ask ourselves if we can simply decompose the constraint instead of developing a global constraint or dedicated filtering algorithm for that constraint. So let's first study what is the possible decomposition of the AllDifferent constraint. So the definition of the constraint is the following. You have an array of n variables, and you would like that no two pairs of variables take the same value. Okay, this is what is expressed here in this expression. So you say that no two pair of variables should take the same value. Okay. The most basic version of that constraint is, of course, for two variables, x and y. And so basically what you say here is that x should be different from y. And the way we will filter that constraint is shown here on the source code. Okay, so we extend, of course, always the abstract constraint class. We have two instance variables that will be initiated by the constructor. The constructor is not illustrated here by lack of space. And then in the post method, what I will do there is that I will register to the event that y is fixed. So whenever y is fixed, then I will simply remove the value of y from the domain of x. This is what we will do there. Okay. And if at the post of the constraint x is fixed, then I will remove from the domain of y the value of x. Okay, and so since I know that y is fixed, getting its minimum simply is the same as getting its value, its current value. That is the only remaining value of the domain. Okay, so that's in the post method. Okay, the post method is executed at the time of the post in the model. But then, if none of these two cases are true, it means that the two variables are not fixed. For instance, let's say the domain of x might be, for instance, 1, 2, 3. And the domain of y could be 1, 2, 3 as well. Okay? So if that's the case, this part will not be executed. And in that case, you just register, okay? You just register the constraint to the event that is fixed and y is fixed. So whenever x or y becomes fixed, this propagate method will be executed. Okay, so that block of code is executed when x or y becomes fixed. Okay, not before. And if one of the two becomes fixed, if it's the case that it's y that is fixed, yeah, then you simply remove from the domain of x the value of y, and otherwise you do the opposite because it means that it's x that is fixed. So you get the value of x, that's the value of x, and you will remove that value of x from the domain of y. Okay, so that's a propagator, a filtering algorithm for the constraint x different from y. As we have seen before, we can express the AllDifferent constraint for n variables in terms of simple binary constraint. We simply need to consider every pair of variables. I is different from j, and if I is different from j, you simply post the constraint that y xi is different from xj, and that's exactly what our not equal constraint that we just have introduced is supposed to do. So we can now define a class that will post for us all these binary constraints to implement the AllDifferent constraints for n variables. So we have no propagate method in this class. We simply do everything in the post method. In the constructor, we just initialize the array of n variables there, okay? And in the post method, we have here a double for loop to consider every pair of variables with I different from j. So we iterate starting from I from 0, and j we will start it from I plus 1, so that we are sure that I and j are not the same. And we will not consider I and j and then j, for instance, the pair 1, 2 and then 2, 1 in the opposite direction, because that's totally equivalent, of course. We don't want to post 2 times the same constraint. And so for every pair I, j with j strictly larger than I, we post here the not equal constraint that we have defined before. We simply post it. Okay, and we say xi is different from xj. So how many constraints do we post overall? We will post order of n square binary constraint. And so more exactly, that's n times n times n minus 1 divided by 2 pairs of constraints.